Hello friends, welcome to Rajesh Data Engineering. In this video, I'm going to talk about AutoLoader in Databricks. AutoLoader is one of the advanced feature provided by Databricks. Even though this is advanced concept, this is mostly used in most of the data engineering Databricks related projects. So I'm going to give idea of what is AutoLoader, when to use that, how to use that. AutoLoader is mainly used for incremental data loading. So in order to understand AutoLoader, first we have to understand what is incremental data load. So let me start from the basics of incremental data load. So incremental data load is one of the most commonly used data loading pattern in data engineering ETL pipelines. So as per this concept, we have to process only the adding new or modified data to the existing data set without reloading the entire data set, which means whenever we are ingesting data from multiple source systems, we have to process only the modified or newly added data. We should not process the entire data. So this incremental data loading pattern, this is one of the complex and most challenging in most of the data engineering projects. So there are multiple approaches in order to handle this incremental data load, but each and every pattern is having certain problem. So coming to AutoLoader, this is going to resolve those problems. So that is what we are going to discuss in this video. So you understood what is incremental data load. Let me explain what is the ideal incremental data load, or what are the characteristics of incremental data load. So as per the thumb rule of incremental data loading, we have to process only the newly added or modified data files. We should not process the entire data, or we should not process non-modified data, right? That is one of the important quality of this incremental data load. And the next one, we have to process the data as soon as it has been detected, or when we receive new file, immediately it should be processed. That is the second characteristics of incremental data load. And coming to the third one, it should not miss any new files. We should not process the previously processed file. That is what we have seen in the first point. Same at the same time, we should not miss any new files. That is also one of the important characteristics. And it should provide good performance. Even though we are having multiple different patterns to handle incremental data load, this is one of the place where we are having challenges. We have to design a incremental data load pipeline with good performance. Even though we are going to have huge number of files under large number of directories, still there should not be any performance bottleneck. And the last quality is it should be repeatable pattern, which means we should be able to schedule, then it should be able to process the same thing in a repeated manner. So these are the ideal characteristics of incremental data load. Even though we are having many incremental data pipelines in the world now, we are having millions or billions of pipelines running across the world to handle incremental data load. But each and every pipeline, they are suffering from some of the issue. They are getting deviated from these ideal characteristics. So in order to avoid that, we are going to introduce AutoLoader. So that we will come to know later. Now, before getting into AutoLoader, again, I want to highlight few common patterns which is used to handle incremental data loading. Right. So coming to the first button, this is one of the traditional and most popular method, which is watermark method. So as per this method, what we are going to do is we will when we ingest data from the source system, we are going to capture the maximum timestamp or one of the incremental ID column. What is the maximum ID? We are going to capture that value and we are going to store it in one of the control table, which is called watermark table. Then, as per our ETL pipeline logic, when the pipeline is getting triggered next time, it will first go to the control table and it will get the value of maximum timestamp or maximum ID. Then it will go back to the source system. Then it will compare whatever the new records, either modified or added, greater than this particular watermark timestamp or ID. It is going to pull only those value. So this is the watermark method, and this is very common and traditional approach, and it is implemented in most of the traditional relational databases and data warehousing. But we have certain problem with this method. Once we have created this solution, then we will create triggers based on a particular interval, which is schedule based, or we can go with event based trigger, right? But coming to the downside of this approach, even though there is no changes to the source system, there is no modified or new data, but still at the scheduled interval the program will start executing. It will go back to the source system and it will just compare with the watermark timestamp, and it will check if there is any new or modified record. When it comes to know that there is no changes in the source system, then it won't execute anything, then the process will be terminated. So the conclusion is, even though there is no changes, but still our program is getting executed. That is unnecessary, because each execution that is associated with particular cost, because of computing platform infrastructure, for these reasons, it is costing something. So even though there is no necessity to execute, but still it is getting executed at the regular interval. So this is one of the downside of this particular pattern. Right. So let us go to the next pattern, which is checkpointing. This is most commonly used in Spark structured streaming. So as per Spark structured streaming, it is not going to check the source system when there is no change. Okay, that issue is getting resolved. But the thing is, it is going to collect the offset value for the processed data, and it is going to store those offset value under the checkpoint location. With the help of this checkpoint location, Spark structured streaming can compare the source and target easily, and it can process only the newly modified or added data. Fine, but the problem with this pattern is, whenever we are having huge number of files, millions or billions of files across thousands or millions of folders, then it is going to recognize performance bottleneck. It's not going to be efficient in order to handle huge amount of data files. So that is the problem with this pattern, checkpointing location. And apart from that, we can go with our own approaches, like we can use Azure Logic Apps, Azure functions. We can go with our own approaches also, different patterns we can design. But each and every pattern, it is coming up with some shortcoming. There is some problem with each and every pattern. So I'm not going to dive into different patterns here. I have covered just two patterns which are very commonly used in today's data engineering projects. Right. Now we have seen, there are multiple patterns to handle the incremental data load, but each and every pattern, it is coming up with its own disadvantages. So what is the best solution? So best solution is, we can go with AutoLoader. So AutoLoader, that is giving the feature of processing the incremental data continuously, efficiently, automatically, as soon as new files arrive. So this is the concept of AutoLoader. So at high level, you understood what is AutoLoader, why we are using. AutoLoader is one of the feature provided by Databricks in order to handle incremental data load. Right. Now, let us try to understand more about AutoLoader. So, AutoLoader, we understood the purpose. It is used to process incremental data efficiently and automatically. And there are certain other limitations, like this is currently supporting only cloud storage systems like Azure Data Lake Storage in Azure, or Amazon S3 bucket, or Google Cloud Storage, DBFS. Now, these are the different cloud storage system we are having in the market. Currently, it is supporting only cloud storage system. And coming to file format, AutoLoader is supporting only certain list of file formats. Those are JSON, CSV, Parquet, Avro, ORC, text, and binary file. These are the file formats currently supported by AutoLoader. Right. We understood what is AutoLoader, and for which source systems, for which file formats we can go with AutoLoader. Right. Now let us try to understand the internal components of AutoLoader. Basically, AutoLoader is having three major internal components. The first one is internal database. So whenever AutoLoader is processing, ingesting data from different source systems, it is storing the metadata of processed files within internal database, which is RocksDB. This is one of the major component. And second component is, in order to process the incremental data, it is using Spark structured streaming concept. So coming to Spark structured streaming, it is processing the incremental data, but it is having certain problem with the file listing. Whenever it has to handle huge amount of data, then it is having certain performance bottleneck. That is actually eliminated with the help of this first component and third component. But coming to processing engine, it's quite similar to Spark structured streaming. And the third component is AutoLoader is using advanced and optimized cloud native components in order to identify new files as soon as they arrive. So with the help of this processed data and also newly available data, with the help of these components, AutoLoader is performing better than Spark structured streaming. Right, these are the components of AutoLoader. We understood. Now, coming to processing, when AutoLoader is processing the data, this is actually having two parts. One is cloud files data reader. This is nothing but identifying the new files and how it is reading from the source system. And the second one is cloud notification services. This is optional. Coming to cloud notification services, there are two internal components. One is there are two internal options. One is directory listing, that is a default one. If you don't specify any option, then it is going to act as a directory listing. But apart from that, one more option, which is file notification method, even we can choose that explicitly. But in order to choose that, we have to grant certain access that I will cover in the next slide. So coming to processing in AutoLoader, it is having two major parts. Right. Coming to file detection mode, as I mentioned in the previous slide, we are having two different file detection mode. One is directory listing mode. Another one is file notification mode. Coming to directory listing mode, that is a default one. We don't need to specify anything explicitly. But coming to file notification mode, for that we have to specify explicitly. And coming to directory listing mode, that is more suitable in order to process the data in batch mode, which means we are getting list of files for every 1 hour or every 6 hours, every 1 day, every week, something like that. We can go with directory listing mode. But if you are getting real-time data in a huge number of files per second or per minute, then it's better to go with file notification mode. Right. I will dive into details for these two modes so that you can get better understanding. First, we can understand directory listing mode. So coming to directory listing mode, as I mentioned, this is the default mode. We don't need to specify that explicitly in our programming. And coming to permission setup, there is no specific permission needed in order to use directory listing mode except access to storage account. Access to storage account, this is not only for this AutoLoader. Even we have to create data frame. We have to read a certain file from any storage. Then we need access to that particular storage account. It is coming in the form of mount point, or we can directly access with a certain key. So even in order to create mount point, we are having different approaches. Like we can use a service principal or access key or Azure Active Directory. There are various approaches. So with the help of those approaches, we need to grant access to the storage account. That is the only thing. Apart from that, we don't need to configure any specific permission, right? And this directory listing, that is more optimized and efficient directory listing program compared to Spark option. Even Spark structured streaming, that is also comparing the list of files under directory and it is processing. But this is completely different from Spark structured streaming. So I'm going to give some example, then you will understand the power of AutoLoader compared to Spark structured uh, structured streaming. Right. In order to give that example, in order to get better understanding, you can you can try to understand this example. Let's say you are processing data from multiple source systems, and your Azure data lake storage, that is divided as per this hierarchy. At top level, we are having source systems, and within that we are having year, within that we are having month, within that we are having day, within that we are having hour. So in real time, we might have multiple source systems, but in this example, I'm just considering only one source system. And one source system, let us assume we are having multiple years, 2021, 2022, 2023. Let us assume only 1 year I'm having currently, 2022. And 2022, that is having multiple monthly folders internally. So there will be 12 folders per year folder. And each month, that is divided into multiple subfolders for each day. For example, for the month of Jan, I will have 31 subfolders. For the month of February, I will have 28 or 29 subfolders. Coming to March, again it will have 31 subfolders. So overall, we are going to have 365 unique folders under this layer, under this level. And coming to each day, again it is subdivided into 24 subfolders, one for each hour. So when we go to this particular level, the number of folders would be, above we are having 365, and for each folder we are having 24 subfolders, which means 365 multiplied by 24, we are going to have 8761 folders per 1 year. Just for simplicity, I'm going to understand, I'm going to assume I'm having 10 files under each folder. So we are having 8761 folder, 10 files per folder, which means overall I'm having 87,610 files. This is one of the simple example I have given, but in real time even we can have very complex hierarchical structure. Even here, if I'm going to consider two more here, then this should be multiplied by two more. And in case I'm going to add multiple source systems, then we have to multiply those many number of times. Then we can understand how many number of files we are going to have. And just in this example, I have considered only 10 files on an average, but in real time we can have thousand or millions of files under each folder. Then we can understand the complexity of this storage, the source system. Right. Now coming to this structure, in order to process these files, and from the root folder, from the the lowest folders, in order to process these files, let us assume we are going to use Spark structured streaming in one use case, and we are going to use AutoLoader in another use case. Then we are going to compare. So as per Spark structured streaming, it is having the concept of one API call per folder. In order to process the newly added or modified files, so it will send one API call per folder. So in this case, we are having 8,761 folders, which means in order to process 8,761 folders, it will send these many number of API calls. And in order to process 87,610 files, it needs 8,761 API calls. But coming to AutoLoader, this is following different powerful algorithm. As per this one, it is going to consider the entire folder in flattened structure. So it is basically flattening the entire structure. And as per ADLS feature, it is supporting 5,000 files for single API call, which means in order to process 87,610 files, it will just send only 18 API calls. And for each and every storage, the file number of files will differ. For example, Amazon S3 bucket, the limit will be something different. Even GCS, it will be different. But coming to Azure Data Lake Storage, it is 5,000, that is the limit. And in order to process 87,610 files, it will just take only 18 API hits. But the same process, Spark structured streaming, it is going to take 8,761 API hits. Then we can easily compare. Here just 18, that is compared with 8,761. Now we can understand the power of AutoLoader, how powerful it is. Now how quickly it can finish the same data ingestion compared to Spark structured streaming. I hope you understood the power of AutoLoader in directory listing mode. Right. Now let me go to the next file detection mode, which is file notification mode. So coming to file notification mode, now this is mostly suitable whenever we are processing millions of files under huge number of directories, and also the data is coming in real time. For each and every minute or every second, we are receiving many files. So for those scenarios, file notification mode is more powerful than a directory listing mode. For file notification mode, we have to grant certain access. Like for Azure Data Lake Storage account, we have to grant contributor access. Same for storage queue and also for event subscription. Okay, we need to grant the contributor access for these services. Once it is done, then AutoLoader will automatically set up the notification and queue services for us. Then it will start using that. We don't need to manually set up anything. But in the program, in order to grant access to queue storage, we have to create a service principal and we have to give certain configuration details through our code. So I will explain in the demo, but before that we have to understand what are the different parameters we need to pass for file detection, file notification mode. So we have to keep these information handy: subscription ID, resource group, tenant ID, client ID, and client secret. Client ID and client secret, that is nothing but service principal credentials. Right. I hope you understood file notification mode as well. Now, finally, I can summarize the architecture of AutoLoader. So for whatever we have discussed, I'm going to summarize in this diagram. So we are having Azure Data Lake Storage. So we have to process the data into one of the medallion architecture in our Delta Lake. So for that, we can go with the Spark structured streaming, but that is not powerful. That's the reason we want to go with AutoLoader. So coming to AutoLoader, there are two different options. Either we can use Event Grid and Azure Queue. This is nothing but file notification mode. So for that, these services will be created by AutoLoader itself automatically, but we have to configure certain things and we need to grant certain access. That's it. So for this method, uh, AutoLoader will consume the metadata from the ADLS and it will just store the processed metadata within the RocksDB. And with the help of this RocksDB and the source system, Spark structured streaming will be able to process the data efficiently into our Medallion architecture. This is one approach. The second approach is this is the default one, option 2. In this option, we don't need to explicitly mention the type. By default, it will be using directory listing. So in the directory listing, basically it is going to list down all the files under the different folders, and it is going to maintain the processed data within the RocksDB. And with the help of this RocksDB and directory listing, Spark structured streaming will be able to pull the unprocessed or modified newly added data efficiently from the source system, and that can be processed and pushed into Medallion architecture within the Delta Lake. This is the summary architecture of AutoLoader. I hope you understood. Now let me get into demo in Databricks. I have logged into my Databricks environment. So in this notebook, I'm going to explain different features of AutoLoader, how to use that practically. So as I mentioned previously, the first step is we have to grant access to the storage account to AutoLoader. So for that, we can use Spark configuration settings. So here what I'm doing is I'm retrieving my Azure storage account details along with access key from the key vault. Even we can hard code that directly, but it's recommended to use key vault because keeping the sensitive information directly in the notebook is not recommended. I have already posted a couple of videos in my channel about Azure Key Vault integration. In case you don't understand how to integrate Azure Key Vault with Databricks, you can watch those videos. Right. So I am retrieving the values, then using Spark configuration command, just I'm configure my Azure Data Lake Storage account details. Once this is done, then AutoLoader will be able to ingest data from the source system. Right, this is one of the prerequisite. Once this is done, in the next step, I'm going to show the basic configuration, the basic way of using AutoLoader. So for that, I'm going to use the syntax spark.readStream. Then within the format, usually we used to give the file format like CSV, JSON. But when you have decided to use AutoLoader, then we have to use the format which is cloud files. Whenever we are using cloud files, it means it is going to use AutoLoader internally. Right. This is how we can invoke AutoLoader. And one of the mandatory parameter is option is we have to specify which file format we are going to process. In our Azure Data Lake Storage, we might have CSV file, we might have JSON file or Parquet file. So what kind of file format we have to process in this ingestion? So for that, we have to specify option. Within this option, we have to tell cloud files start format, that is JSON. In case you have to process a CSV file in your project, you can give CSV. Right. This is one of the very simple example how to use AutoLoader. And apart from that, we are having so many features, so many options available in AutoLoader processing that I am going to explain in the subsequent steps. So in the next step, I'm going to tell schema as well. So this is similar to any data frame reader. So while reading data frame, while creating data frame, we used to specify this option. We used to define the schema explicitly with the help of struct type and struct field. Then we used to mention that. That is recommended for good performance. In case we are going with infer schema, then unnecessarily Databricks engine will scan the data files once in order to derive the schema. But that is very costly operation in regular Spark processing. But coming to AutoLoader, even that is not very costly because AutoLoader efficiently samples the data to infer the schema. So even we can go with infer schema option. For that, we have to go with option cloud files infer schema type true. By default, it is false. But if you want to go with infer schema option, then we can give this option. And along with this option, we should give schema location as well. Once we have created this infer schema, where we have to store that information. For that, we can give location of our choice. It could be ADLS or DBFS. Right. These are the different options. We can explicitly define the schema and use, or we can ask the AutoLoader engine to infer the schema. Right. Apart from that, we can specify schema hints as well. So in this example, whenever I am telling AutoLoader to infer the column type, let's say I'm having one column employee ID, which is having all the numerical values, but Databricks AutoLoader might infer that as integer. Let us assume that column should be big integer instead of regular integer. Then what I can do is only for those particular columns, I can give hints as well. So here I'm giving schema hints, then employee ID column, it should be big integer. So even though you are inferring as an integer, don't use integer. It should be big integer. So this is one of the other option. So similarly, here I have covered few options. With the help of this option command, we can specify. So there are so many different options available. We can use any option as per our use case, our requirement. This is so far I have talked about directory listing mode only, because explicitly I didn't mention that notification service. Now in the next example, I'm going to show you how to use this notification. So for that, file notification mode, we have to use this syntax. We have to give option cloud file start use notification true. By default this is false, so it will use directory listing mode. So whenever we have to use file notification mode, then we have to use this syntax. And as I mentioned earlier, whenever we have to use file notification mode, we have to grant access in Azure portal for Azure data lake storage account, Azure queue, and event grid. Once that is done, and also we have created service principal, then even we can pass these parameters along with AutoLoader. So for that, in my next example, what I have done is I'm creating one variable here, cloud files conf. We can give any variable. In this example, I have given this variable. Within that, I am defining all the parameters along with its value with the help of key value pair. It's a kind of Python dictionary. It is having key value pair. So here one side I'm having all the parameters, and other side I'm keeping all the values. So here I have given all the parameters. Then while reading the data, what I can do is just I can pass all these values in one go. Here I have defined the options in the above variable. Now I am using that variable. So this variable is key value pair. That's the reason we need to give star star. In case it's array, we can give only single star, but it's a key value pair. That's the reason we need to give star star. And earlier I have given only option so far, but here it's a multiple option. That's the reason here we have to give options, not only option. We have to give yes also. Right, this is how we can use file notification mode as well. I hope you understood. And apart from that, here I have summarized different options, AutoLoader options. I'm not going to dive into details, but quickly I can walk through. First one is file format. Okay, which type of file we have to use for our ingestion, that we can specify. And the next one is allow override. In case there is some changes to the existing record. Let's say in our existing value for one of the employee, the salary is 5,000, but in the source it's 6,000. There is some change. Then we have to overwrite the existing record. So this is a default property, but in case you don't want, you can change as well. And coming to schema location, in case we are going with infer schema, then where we have to store that schema information. So for that, we can define schema location. The next property is schema evaluation mode. And today's big data world, schema evaluation, that is one of the important concept. AutoLoader is efficiently handling schema evaluation. So basically with this property, we can play around this schema evaluation. Basically, it is giving different modes, schema evaluation modes to handle schema evaluation. So I have given different schema evaluation mode as well below. By default, it is going to use add new columns. So let's say in our target table, we are having 5 columns. In the source, we are getting 6 column. So one new column we are getting. Then what happens? Our streaming pipeline will fail. Then the new column will be added. After that, the streaming process will be restarted. This is the default mode. And coming to rescue, in the rescue mode, it is not going to add the new column to the target, but instead of that, it is going to create one column which is called underscore rescue data. Within that, it is going to document what are the new columns we have received. And at the same time, it is not going to fail the streaming process, that is rescue. And the next one, fail on new columns. Let's say we are processing some sensitive data, we are not expecting any new column to arrive, but in case something is coming that is unexpected, then it should fail. So for that, those scenarios, we can go with fail on new columns. And the streaming pipeline will be failed, it will not restart automatically. We have to fix the schema issue, then only it will restart. And coming to the last one, none. Just totally ignore whenever we are getting some new schema, which means it is turning off schema evaluation feature. That's it. These are the different options available for schema evaluation mode. And coming to other options, schema hint I have already covered. In case for a particular column you want to specify particular data type, then we can go with that. And infer column types, in case you don't want to go with user defined schema, then we can go with this one. And include existing files, which means whenever we are setting up this entire autoloader process for first time, and you are pointing to some data folder, but there are already files are available, so the previously available file we have to consider or not. That property is handled with the help of this option. And the next one is max byte per trigger. So whenever we are processing the incremental data, basically it is triggered. Maybe it could be once, or it could be micro batch, or it could be continuous. But for each trigger, how much data it can fetch at a time, that property is defined with the help of this option. And the next one is maximum file age. This is one of the important parameter in order to handle the duplicate files. So let's say I'm going to set 1 hour is the maximum age for all the files. So within 1 hour, I'm going to get to two different data files with same name, then it will be considered as duplicate. But after 1 hour, let's say last 1 hour I got one file, and after completing next hour, again I'm getting the same file, then it will be treated as a new file. So in order to define the duplicate file, this property is very important. And coming to resource tag, this is kind of this is helping to identify the right resources. This is not very commonly used. And this next one is very important property, validate option. So basically we have defined different options in the above step. So we have to validate those options or not. For example, in your code, for one of the option you might have given wrong value. If you have given wrong value, that will be ignored and it will be it will be proceeded. But you have given certain option, it's very important option, it should have received the right value. That value should be considered. So you want to validate, then you can give this option, which means whatever the options we have specified in our autoloader ingestion, everything will be validated. In case a certain value is incorrect, then it is going to report. So in that aspect, this is one of the important parameter. And we are having backfill interval, for what duration we have to consider the backfilling, that is defined with the help of this parameter. And the last one is partition column. This is actually using hive style partition. So whenever we are ingesting the data from the source system, in case the source system is partitioned based on the folder, usually this is following this style, country equal to UK, or city equal to certain city. So basically, the hive style partition, in case the source system is following hive style partition, then that can be used for autoloader ingestion. So these are the different commonly used options in autoloader. I hope you understood. And apart from that, while processing data through autoloader, we can consider wildcard options also. Wildcard option, that is nothing new to you, because this is very common in most of the programming languages. Question mark, which means matching any single character. Star, which means matches zero or more number of characters. So there are various options I have given, so you can have a quick look on that. This is nothing new. This is similar to any programming languages. This wildcard option, this is commonly available with most of the programming languages. All right. So how to use that? So while reading the data using autoloader, first we have to give a format, cloud files. Then we can define different options. Then we can define a schema as well. Then here we can use the wildcard path. So for example, under root folder, I want to consider all the subfolders. That's the reason star means any. So we can use any wildcard option while reading the data from the source system. And finally, once we have ingested the data from the source system, we have to write the data into our target system. In the medallion architecture, we have to write the data within bronze, silver, or gold layer. So for that, we can use write stream command. So df.write stream. Then trigger, there are multiple options for trigger. Either we can use once, or we can go for each batch. Now there are different options we can use. And finally, we have to use save and our target location in the medallion architecture. This is how we can use autoloader in our real-time projects. I hope you understood the concepts of autoloader, how it is working internally, how to use in our project practically. I hope you understood. Hope you enjoyed this video. If you like the content of this video, please like and comment in the channel. Please subscribe this channel and don't forget to click on the bell button to get latest videos on Databricks. Thank you.